Good day, everybody. I'm absolutely delighted to have you here today. For you grade 7s, this is going to be lesson 1, algebra. And the person to handle your lesson today is yours truly. Please welcome Prof. B. Thank you very much. While I was preparing for this session, I came across a cartoon which I would like to share with you. And there you have it. Now for the serious stuff. Today we will be doing some revision looking at what we did last year. And last year we had a look at our numbering system, the base 10 system. We call it the base 10 system because it consists out of 10 digits. There are other base systems as well, but that is for a later lesson. Every digit in a decimal number has a position, and these positions are very important, as we will see just now. In our decimal number, we will find a decimal comma or a decimal point. This decimal comma or point separates the whole number and the fraction, and it helps us to understand what the value of each digit is. And what is numbers, numerals, and digits? Can you remember? A numeral is just a symbol that represents a number. For example, that symbol represents a number 5. That symbol represents a number 99 or 99. That symbol represents the number 6, and we call them numerals. A number is a count or a measurement, and that is very important because that gives value to this numeral. And the number consists out of digits from 0 to 9, and the position of that digit determines the value of it. Let's look at the number 374,589. 374,589. What is the place value of each one of these digits? Let's run them down. The 4 is in the position of 1,000, so it should be there. The 8 is in the position of the tens, so it should be there. The 7 is in the position of the 10,000s, so it should be there. The 3 is in the position of the 100,000s, so it should be there. The 5 is in the position of the hundreds, so it should be there. And the 9 is the position of the units. Because in our numbering system, you start with the units, and if you multiply by 10, you get 10. If you multiply it by 10, you get 100. If you multiply it by 10, you get 1,000. Multiplied by 10 is 10,000. And multiplied by 10 is 100,000. Thus, this digit say 300,000, 70,000, 40,000, 500s, 80, and 9. We can also write this number in what we call an expanded notation, which will be 3 times 100,000, which is 300,000. 7 times 10,000, which is 70,000. Plus 4 times 1,000, which is 4,000. Plus 5 times 100, which is 500. Plus 8 times 10, which is 80. Plus 9. Just remember, the difference between the digit and the number is that the number consists out of digits and the place of where that digit is determines its value. Let's do a few examples. In this example, 783,405, the 8 is in the position of the 10,000s, so it will be 80,000. Got it? Right, let's go here. The 9 is in the position of the 100,000, so it's 900,000. The 2 is in the position of the million, so it is 2 million. The 1 is in the position of the 10,000s, so it's 1 times 10,000, that's 10,000. Now let's write some numbers in a expanded notation. And yeah, here's a tricky one. This one example is quite easy. The 8 is in the 100,000, so it's 800,000. The 4 is in the 10,000, so it's 40,000. The 3 is in the position of the 1,000, so it's plus 3,000, plus 500, plus 60, plus 4. That's easy enough. But let's have a look at this guy. The 2 is in the position of the, there we already have a million, 10 million, 100 million. So the 2 is in the position of 100 million, so it is 200 million. The 5 is in the position of the 10 million, so it's 50 million. The 4 is in the position of the million, so that's plus 4 million, plus 400,000, plus 80,000, plus 6,000, plus 100, plus 20, plus 3. I'm sure you got that right. Let's have a look at this one. The 4 is in the position of the 100,000, so it's 400,000. The 80 is 80,000. 7 is 7,000. That 7 is 700. That 5 is 50. And that 1 is units, which is 1. Easy enough. This one, 4 is in the position of millions. Plus 7 is in the position of 100,000, so 700,000, and so we go down to 80,000 plus 5,000 plus 0 times 100 is 0 plus 20 plus 4. Just have a look here. Very important, that is a 0. Let's have a look at place values. Tell me what is the place value of 5, each of the following numbers. 5 in this number is 100,000, so it's 500,000. 5 in this one is in the thousands, so it's 5,000. The 5 here is in the position of the 10,000s, so it's 50,000. This 5 is also in the position of the 10,000s, so it is also 50,000. 5, 50,000, 50,000. Next example. Let's take 297,654. What must we do to it to get it to 297,604? Well, that 5 over there must become a 0, which means I must take 5 away from there, and that is in the place position of the tens, so it is minus 50. Good. Let's have a look at this one. I have 489,568, and I want to bring it down to 409,568. Again, this 8 here must become a 0, so I must take 8 away, but it's in the 10,000s of positions, so it will have to be 80,000. This one here, I've got 478,964, and I want to make it 458,964. Again, that 7 there must become a 5, so I have to take out off 2 from the 7 in the 10,000 positions, which will therefore be minus 20,000. Minus 80,000 here, minus 20,000 there. Look at this one here. Complete the table and always add and subtract the number from the original number, and this is the original number. If I add 10, it means that 4 becomes a 5, and it is then 433,358. Subtract 10, it means I take 10 away there, so it becomes 338. Add 100, add 100 there, so we add 1 there, and it becomes 433,448. Subtract 100, now we take 100 away from there, and it becomes 248. Add 1,000, we need to add 1,000, which means add there, and becomes 434,348. Subtract 1,000, which means now we're going to take 1 away from the thousands position, and it is 432,348. Add 10,000, which means we're going to add 1 there, which makes it 443,348. Subtract 10,000, which means we're going to subtract 1 there, and it becomes 423,348. Now, let's see you do the following one. I'm going to give you a few seconds and see if you can do it. Check your answers. That wasn't too difficult, was it? Good. Now, find the place value of the 2. This 2 is in the position of the 10,000, so it's 20,000. Same with this one, it's also in the position of the 10,000, so it's 20,000. This 2 is in the position. Here is a bit of a brain teaser for you. The teacher has enough sheets of paper, and she's going to divide them between learners, and each learner is going to get 3, but when she does that, she's got 31 sheets left. Or, because now we haven't got enough information, so we need some more information. Or, if she would give each learner 4, she would have 8 left. So how many sheets does she have? We're going to start at the bottom one, 24, because this one can't work. If I take away 31 from 24, it can't work. So we can scratch that one out. Let's have a look at the 91. If I take the 31 sheets that is left over away, that means she dished out 60. Each pupil got 3, so there should have been 20 pupils. One is a possibility. Let's test the 100. If you take the 31 sheets away that was left over, she must have dished out 69, and if every pupil got 3, we get 23, which means there should have been 23 pupils. Now, so it's either one of these two scenarios. Now let's look at this scenario. We know we're not going to try the 24 because we've already seen that's not going to work. So let's try the 91. Now in the second scenario, there's 8 sheets left, which means she's dished out 83 if we take 91. But 83, we cannot have 4 sheets per learner because 83 is not divisible by 4. So this one is not going to work. Let's try this one. If I take 8 sheets that was left away from possible answer 100, which means she dished out 92. If every learner got 4, 4 goes into 92 23 times, which is the same answer than we got there, which means the 100 satisfies that condition and that condition, so our answer is 100. Good luck with that one. Bye for now. See you in the next session.